Hello, this is going to be our honors week 23 homework. So we're going to take ourselves through some of these equation solving pages to get ourselves reviewed back up on our equation solving, and then we'll get into the last page, which is just doing some factoring here for us. Okay, so on this first page here, it says we have some like terms. Right, what like terms means is things that can be combined because they're on the same side of the equation. So when I look at number 1 here, see we've got a negative 8 plus an x minus 3x is equal to a 14. Right, so a common misconception here will be is that people try to take the wrong step. They will try to do it like this. They'll try to add 3x there, and they'll try to add 3x there, but that's not right. Right? This is not right. That's what we do if variables are on both sides of the equation. For this one, though, they're already on the same side. So we won't try to move them with addition and subtraction. We'll just put them together because they are like terms. So we'll really have a negative 8 minus a 2x, because x minus 3x gives me a negative 2x, is equal here to a 14. Then once we get it there, it's just solving a two-step equation. Right? So I'll need to add 8 to both sides. And then we'll need to divide both sides by that negative 2. Make sure you are dividing by that negative sign, though, because if you miss that out, then you're on a multiple choice test. You're going to get that wrong answer. We get that x is equal to a negative 11. Okay? Now, something on these types of problems, when we are like terms, if you take a look down here to number 7, although these variables are not sitting directly right next to each other, they are still on the same side of the equal sign. All right, so I still will not do this. I still will not put plus 3x plus 3x. It's even more tempting to do that on this problem, right? But if I was to do this, this is wrong. This is wrong, right? I cannot do that. They're already on the same side of the equation, right? Instead, we just put them together. Make sure you do note the signs in front, though. Okay, so we've got a 2x. If we lose 3x, we're down to just a negative x. Then we have our minus 5 is equal to an 8. Right? Then from there, it's just solving our equation out for the rest of the way. So we'll add a 5 and add a 5. We'll have a negative x is equal to a 13. So on this, we're thinking about dividing or multiplying both sides by a negative 1 to get those negatives to cancel out. And there would be our final answer. Okay? Here we have our second page, distributing with parentheses. Right, so before we try to combine any like terms, so for example, say on number 2, before you try to combine this 5x with the x, we can't do that yet because we have to do our order of operations first. So before we can combine these, right, so that would be a wrong step, we're going to need to go ahead and do our distributing. So we'll take this 6 times the x, the 6 times the negative 4 here. So our 5x stays the same. Then we have a plus 6x. And we have a minus 24. And we're all here equal to a 75. Now, once you get into this problem here, it's just like the other page. Right? You'll combine your like terms since they're on the same side of the equation. And then you can just solve out your two-step equation to where eventually you get your x is equal to some type of number. Right? But remember to distribute on these first. Right? It's going to be important that we do distribute these first. Okay? Now here's where things are going to change up a little bit. And this is we have variables on both sides. All right, so when there's variables on both sides, right, you can see our equal sign here. You can think about it as like a dividing wall in between these two. I cannot put these two together. Right? They're on different sides of the equation. They can't meet. This is where we get to move them using addition or subtraction. Doesn't matter which one you want. You can either move this one or this one. Right? And I'll just choose to subtract 6x from both sides. Right? Could you have chosen to subtract 8x from both sides? Yes, you'd still get the same answer. Right? Once we get it there, once we address that variables on both sides, we're good to just solve a two-step equation here. Right, so maybe we'd add our 14, divide by the 2, and we'd be able to get our x is equal to a final answer. Okay? Now, so like for example here on number 4, you can move either one of these pieces. You can either subtract 3x from both sides, or if you wanted to, you could also add 6x to both sides, right? And that would work too. All right? So the whole point of dealing with the variables on both sides is because now we only have our variable on one side, and we can solve this using a two-step equation, right? So you'll finish solving it, and you'll get that your x is equal to some type of final answer. Alright, so this is distributing with parentheses again. The only thing to notice is that sometimes there's going to be a negative sign with our number, so you'll have to keep that in mind. That's the only thing different between this page and the other one where we're doing this process. Right, then from there it's just like it always been. But just be sure to notice if there's a negative sign out in front of those numbers, you do have to bring it along with you. And then we just combine our like terms. And you can solve your two-step equation and reach your final answer. All right, so that should help us out on those equation solving pages. Now the last page is just our factoring trinomials when we do have a number out in front. All right, but what it's saying is that 3 of these have a GCF. Always check for a GCF first. So somewhere within these problems, right, so there's 8 here on the first page. There's several more on the back page here. 3 of them will have a greatest common factor. Right, and you'll have to look. So say, for example, I'm here on number 1. I'd ask myself, is there a GCF? I'm looking at those. Is there a number I can divide 3, 2, and 5 by? No. There's not. So we don't have a GCF. So what that means is I'm going to just start finding my factors, right? So we need our factors of our first number that are also factors of our 2 here. All right, and it's a negative 2, so that means that with our terms, one of them is going to have to take on a negative sign, and all of this has to add up to give me a negative 5. All right, so my factors of 3 are 1 times 3. Factors of 2 are 1 times 2, where one of them has to be negative. I need to find the right combination to get these to add up to a negative 5. This one doesn't have too many, so it's not too hard to see. It would be a 3 times a negative 2, which gets us a negative 6. 1 times 1 gets us our 1, so that does equal a negative 5. All right, so then we go to set up our answers. All right, so I need a 1x and a 3x, well, it's a p in this case, a 1p and a 3p to get our 3p squared. All right, now remember, these are our distributing arrows, so this 1 needs to be opposite of this one. This 1 needs to be opposite of this 1. Right, this 3 needs to be opposite of the negative 2. Okay, now remember on these, always check for a GCF first, right? So you may get down to some of the other numbers and you'll be stuck thinking there doesn't have a GCF, yes or no. Otherwise, these shouldn't be too bad for us, right? So on this one here, on number 8, right, GCF, yes, find it. All right, so after you do this, you should have a number out in front, and everything in here should be divided by that number, right? That's how our greatest common factor works. Now, in this case, we can see here that it is a 3, right? I can divide all of these numbers by a 3. So then we'd have a 3k squared. We'd have a plus 22k, and we'd have a plus 7. All right, so now we'd still set up our table here. But in our table, we're looking for the factors of these numbers here. So what numbers multiply together to give me a 3? What numbers multiply together to give me a 7? To where all of these can add to give me a 22. All right? And we know that our answer here is going to have this 3 out in front for sure. We can go ahead and put that there already. We know it's there. Okay? So now we're just looking for our correct combinations. So we know a 1 times a 3, a 1 times a 7. This one's not too tough either, right? Because the 3 times the 7 gives me a 21. 1 times the 1 gives me a 1 here. So I know I need a 1k and a 3k. Okay. And then now this 1 needs to be opposite of this one. This 3 needs to be opposite of this 7. So there would be our answer. All right. So this one had a GCF. Okay. So we found one of them. So that means there's 2 left over. All right. Always check first. Always check first. Right, because if we wouldn't have found our GCF on this one, we would have been dealing with too large of numbers, right? And our answer would also have not been all the way simplified. So always look for that greatest common factor first.